8.
New Zealand ready for Issat.
7.
Malaysia sedia untuk Issat.
Roku.
日本は Issat の準備ができています。
5.
Indonesia siap untuk Issat.
4.
England ready for Issat.
3.
Brazil pronto para o Issat.
2.
Issat Janda Prastet Bangladesh.
1.
Australia ready for Issat.
'Wilujeng Sumping di Issat 2020. Wilujeng Nyaksel.
Issat 2020 Flashback. Followed by 12 countries. $183 papers submitted. $108 papers accepted and published by Atlantis Press. Thank you for Issat 2020. Are you ready for Issat 2021?
The International Seminar of Science and Applied Technology is organized by Polytechnic Negeri Bandung to build a culture of international seminars and publications in the field of applied science and technology. The keynote speakers not only have international publication achievements, but also industrialization experience from the results of research conducted in the engineering and non-engineering fields. Issat 2021 invites governments, academics, practitioners, and industries from Indonesia, Timor-Leste, United States of America, Taiwan, Malaysia, Nigeria, Japan, Bangladesh, Russia, and New Zealand to talk together in an effort to solve the challenges in research and innovation in new normal era. Welcome to Issat 2021. Issat 2021 present keynote speakers Alexander Vyboshik, PhD from South Ural State University, Chelyabinsk, Russia. Professor Christopher Gunn from Lincoln University, New Zealand. Professor Sumeru, PhD from Politeknik Negeri Bandung, Indonesia. And will be moderated by Transmisha Semiawan, BScs MIT, PhD from Politeknik Negeri Bandung, Indonesia.
Wilujeng Sumping di Issat 2020 hiji. Wilujeng nyakseni. And to all country, are you ready for Issat 2020?
Bisna Sarah.
Uni Emirat Arab Jahiz lil Issat.
Siyi,
Taiwan, Junpei Cincin Issat.
Des,
पाकिस्तान ऐसो किन्नीत आहे.
Nine,
Nigeria sendiri di Issat.
8,
New Zealand ready for Issat.
7,
Malaysia sedia untuk Issat.
Roku,
日本はアイサットの準備ができています。
5,
Indonesia siap untuk Issat.
4,
England ready for Issat.
3,
Brazil pronto para o Issat.
2,
Issat Jangda Prastet Bangladesh.
1.
Australia ready for Issat.
Wilujeng Sumping di Issat 2020. Wilujeng Nyaksen.
Angkatnya gandean, bangun kaya karingan, nganggo sinjang lamban, mojang priangan, dirang suka kabayan, namihan cahayana, dan dosan sederhana, mojang priangan, munisang ayam, munising jalan-jalan, muni eropena, mojang priangan, mojang
Issat 2020 Flashback. Followed by 12 countries. $183 papers submitted. $108 papers accepted and published by Atlantis Press. Thank you for Issat 2020. Are you ready for Issat 2021?
The International Seminar of Science and Applied Technology is organized by Politeknik Negeri Bandung to build a culture of international seminars and publications in the field of applied science and technology. The keynote speakers not only have international publication achievements, but also industrialization experience from the results of research conducted in the engineering and non-engineering fields. Issat 2021 invites governments, academics, practitioners, and industries from Indonesia, Timor-Leste, United States of America, Taiwan, Malaysia, Nigeria, Japan, Bangladesh, Russia, and New Zealand to talk together in an effort to solve the challenges in research and innovation in new normal era. Welcome to Issat 2021. Issat 2021 present keynote speakers Alexander Vyboshik, PhD, from South Ural State University, Chelyabinsk, Russia. Professor Christopher Gunn, from Lincoln University, New Zealand. Professor Sumeru, PhD, from Politeknik Negeri Bandung, Indonesia. And will be moderated by Transmisha Semiawan, BScs MIT, PhD, from Politeknik Negeri Bandung, Indonesia.
Wilujeng Sumping di Issat 2020 hiji. Wilujeng nyakseni.
Saha anu bisa nyusul tanang
And to all country, are you ready for Issat 2020?
Bisna Sarah.
Uni Emirat Arab Jahir Lil Issat.
Siyi,
Taiwan, 준비 친칭 Issat.
Des,
पाकिस्तान ऐसो किन्नत किया है
9,
Nigeria sendiri di Izzat
8,
New Zealand ready for Issat.
7,
Malaysia, sedia untuk Issat.
Roku,
日本はアイサットの準備ができています
5,
Indonesia siap untuk Issat.
4,
England, ready for Issat.
3,
Brazil pronto para o Issat.
2,
Issat Jangnya Prastet Bangladesh.
1.
Australia, ready for Issat.
Wilujeng Sumping di Issat 2020. Wilujeng Nyaksen.
Angkatnya gandean, bangun kaya karingan, nganggo sinjang lamban, mojang priangan. Dirang suka kabayan, namihan cahayanan, dan dosan sederhana, mojang priangan. Mundi sanggul ayun, mundi sinjang lenjang, muni eropeno, mojang priangan, mojang
Issat 2020 Flashback. Followed by 12 countries. $183 papers submitted. $108 papers accepted and published by Atlantis Press. Thank you for Issat 2020. ready for Issat 2021?
The International Seminar of Science and Applied Technology is organized by Politeknik Negeri Bandung to build a culture of international seminars and publications in the field of applied science and technology. The keynote speakers not only have international publication achievements, but also industrialization experience from the results of research conducted in the engineering and non-engineering fields. Issat 2021 invites governments, academics, practitioners, and industries from Indonesia, Timor-Leste, United States of America, Taiwan, Malaysia, Nigeria, Japan, Bangladesh, Russia, and New Zealand to talk together in an effort to solve the challenges in research and innovation in new normal era. Welcome to Issat 2021. Issat 2021 present keynote speakers Alexander Vyboshik, PhD from South Ural State University, Chelyabinsk, Russia. Professor Christopher Gunn from Lincoln University, New Zealand. Professor Sumeru, PhD from Politeknik Negeri Bandung, Indonesia. And will be moderated by Transmisha Semiawan, BScs MIT, PhD from Politeknik Negeri Bandung, Indonesia.
Wilujeng Sumping di Issat 2020 hiji. Wilujeng nyakseni.
And to all country, are you ready for Issat 2020?
Business alright.
Uni Emirat Arab Jahir lil Issat.
See ye?
Taiwan, 준비 친친 Issat.
Des.
Pakistan esok kini iahe.
Nine.
Nigeria sendiri di Issat.
8.
New Zealand ready for Issat.
7.
Malaysia sedia untuk Issat.
Roku.
日本は Issat の準備ができています。
5.
Indonesia siap untuk Issat.
4.
England ready for Issat.
3.
Brazil pronto para o Issat.
2.
Issat Jangnya Prastet Bangladesh.
1.
Australia ready for Issat.
'Wilujeng Sumping di Issat 2020. Wilujeng Nyaksel.
Angkatnya gandean, bangun kaya karingan, nganggo sinjang lamban, mojang priangan, dirang suka kabayan, namihan cahayana, dan dosan sederhana, mojang priangan, mundi sanggelayang, mundi sinjang lanjang, mundi erok benang, mojang priangan, mojang
Issat 2020 Flashback. Followed by 12 countries. $183 papers submitted. $108 papers accepted and published by Atlantis Press. Thank you for Issat 2020. Are you ready for Issat 2021?
The International Seminar of Science and Applied Technology is organized by Politeknik Negeri Bandung to build a culture of international seminars and publications in the field of applied science and technology. The keynote speakers not only have international publication achievements, but also industrialization experience from the results of research conducted in the engineering and non-engineering fields. Issat 2021 invites governments, academics, practitioners, and industries from Indonesia, Timor-Leste, United States of America, Taiwan, Malaysia, Nigeria, Japan, Bangladesh, Russia, and New Zealand to talk together in an effort to solve the challenges in research and innovation in new normal era. Welcome to Issat 2021. Issat 2021 present keynote speakers Alexander Vaiboshik, PhD, from South Ural State University, Chelyabinsk, Russia. Professor Christopher Gunn, from Lincoln University, New Zealand. Professor Sumeru, PhD, from Politeknik Negeri Bandung, Indonesia. And will be moderated by Transmisha Semiawan, BScs MIT, PhD, from Politeknik Negeri Bandung, Indonesia.
Wilujeng Sumping di Issat 2020 hiji. Wilujeng nyakseni.
Ladies and gentlemen, we will begin our event shortly. Please take your seats. Ladies and gentlemen, we will begin our event shortly. Please rise for our national anthem, Indonesia Raya. Ladies and gentlemen, you may now take your seats. Ladies and gentlemen, get ready for the performance of Rempang Kendang Dance by Kabayan, the students of Politeknik Negeri Bandung. featuring Dr. Jacob Astor. Hello, ladies and gentlemen. I am Nadira Azara, and I'm so honored to be your Master of Ceremony for International Seminar of Science and Applied Technology 2023. So I would like to welcome you all to International Seminar of Science and Applied Technology 2023. Wow, that was such a spectacular performance, but I'd love to tell you the story of what this dance is about. So the Rabakadang dance, originating from West Java, is a fascinating cultural heritage that encapsulates human harmony and nature through movements that reflect a commitment to saving the environment, the use of sustainable tools, and enchanting natural background. So ladies and gentlemen, thank you for coming. All right, so today in our lovely city in Bandung, to be exact, in Bandung State Polytechnic, is such a special day. We have guests from all over the world joining us here in Issat to talk together about natural resources management for environmental sustainability. I am honored to welcome you all, our presenters, our viewers who have come all the way from Taiwan, Malaysia, Timor-Leste, and also Indonesia to talk together in our event. And of course, I would like to say hello and welcome to our online viewers joining us from online platform from all over the world. But before we begin, I would like to see your enthusiasm for Issat 2023. I'd like to ask each and every one of you, are you ready for Issat? But I'd love to ask you, are you ready for Issat? But you answer in your own language, all right? Because we gather here from different parts of the world with different cultures and also different languages. So I'd love to see the diversity, all right? Well, where should I start? All right. Hello, miss. You guys look wonderful today. How are you?
Fine, thank you.
I'd like to ask you, where are you from?
Kuching, Sarawak, Malaysia.
Oh, wonderful. All right. So is this your first time in Bandung, Indonesia?
This is my second time.
Oh, second time. What did you do in your first time, if you don't mind me asking?
Vacation.
Oh, yeah, vacation. All right. So I want to ask you, are you ready for Issat? But I want you to answer in Malaysia. So I ask, Malaysia, are you ready for Issat? And you answer, Malaysia, ready for Issat, but in your own language, all right? Yeah. Okay. All right, so Mr. is going to say, all right. Wait, let me ask you as well. What's your name?
Kang.
Okay. Mr., you look very sharp for today. All right. Malaysia, are you ready for Issat?
Malaysia bersedia untuk Issat.
Give a big round of applause for Malaysia, everybody. Thank you, sir. Thank you, ma'am. All right, let me take this for you. Let's see which other countries that we have. Hello, ma'am.
From Taiwan.
Oh, you're from Taiwan. Do you mind holding this? All right. Where are you from?
We are from Taichung, Taiwan.
All right, wait. Let me say, 你好吗?
我们很好.
All right. Okay, so is this your first time in Indonesia?
This is my first time. This is
Third time.
Third time. Wow, you've been here a lot of times. What do you do in Indonesia?
To Polban.
Oh.
That's why I'm here.
Oh, yeah. All right. So I'd love to ask you again. Taiwan, are you ready for Issat? And you answer in your own language, okay? What do you say?
准备好了.
Okay. All right. Ready, sir, ma'am? All right. Taiwan, are you ready for Issat?
准备好了.
准备好了.
All right, wait. That was wonderful, but let's do one more time if you don't mind, all right? Okay. Taiwan, are you ready for Issat?
我们准备好了.
All right. Give a big round of applause for Taiwan. All right. Hello, sir.
Hi.
Where are you from?
We are from Timor-Leste.
Timor-Leste. All right. Are you the presenters or?
Presenter also.
Oh, I see. You guys look very ready for today's Issat. Yeah, you guys look neat and very enthusiastic for this. All right. So I'd like to ask you: are you ready for Issat? And you answer, all right? Okay. But before that, is this your first time in Bandung, Indonesia?
No, I will proudly say that I'm alumni from Polban, the first student here.
Give a big round of applause.
Like a first international student here.
Oh, you're the international student in Polban. Wow. All right. What is your major, if you don't mind me asking?
Because I think yours is very nice.
Okay. All right. So I'd like to ask you, are you ready for Issat? All right. And you answer in your own language. Ready, sir? All right. Timor-Leste, are you ready for Issat?
Timor-Leste pronto para Issat 2023.
That is amazing.
That is Portuguese language because our official language is Portuguese.
Oh, all right. Wait, let's see in your Portuguese as well. Is that okay? We like the diversity, everybody. All right. Timor-Leste, are you ready for Issat?
Timor-Leste pronto para Issat 2023.
Amazing. All right. Well, thank you very much, sir. Good luck on your presentation. Well, we have already from Malaysia, Taiwan, Timor-Leste, and what else do we miss? There's one more. Wait, where do we live? Indonesia. All right, I forgot. All right. Hello, sir. Okay. How are you? Sorry.
Yeah, I'm good today.
All right. What is your name?
My name is Aditya.
Okay. And are you a student or a lecturer?
I'm a lecturer here in Polban.
What major?
In civil engineering.
Ooh, civil engineering. Awesome. All right. You are the representative from Indonesia that I asked. So I'd like to ask you, are you ready for Issat? And you say Indonesia, ready for Issat. All right?
Okay.
I like to see your enthusiasm because you're from Indonesia. Okay? All right. Ready? Indonesia, are you ready for Issat?
Indonesia siap untuk Issat.
All right, amazing. Well, let's do one more because the audience behind, I think you guys are students, correct? All right, so I want you guys to yell out, okay? I want to see your enthusiasm, okay? Okay, ready? All right. Indonesia, are you ready for Issat? All right. All right, ladies and gentlemen, that was awesome. I love your enthusiasm for today's Issat. So, ladies and gentlemen, I am Nadira Azara as your Master of Ceremony today. I would like to say welcome to International Seminar of Science and Applied Technology 2023. Well, now, before we begin, it is my privilege to invite the introductory remark from the head of research and community service. This man is the person who behind this big event, and he is the person who can make Issat throughout the years come true. Ladies and gentlemen, give a big round of applause for Dr. Jacob Astor.
Assalamualaikum warahmatullahi wabarakatuh. First of all, I want to ask Mr. Marwan Shah. So, how was my dance? Good enough? Cool? Thank you. Okay. I want to greet my friend from Malaysia. Where is Mr. Kang? Mr. Kang? Okay, sorry, could not accompany you in Bandung because I'm very practice very hard for this dance. You can smile. This is joke. Okay, for the sake of this event, I willing to dance for all of you. Please give big applause for this event. Okay, ladies and gentlemen, I represent the chairman who is currently in United Kingdom to give a speech this morning. Issat 2023 was attended by representatives from 7 countries. We received 112 manuscripts, but only 98 high-quality papers were accepted to be presented in this event. Issat 2023 would not be how it is without the support from director, vice director, all staff at Polytechnic Negeri Bandung, and all participants to sharing and presenting their research in this seminar. Special thanks go to Polytechnic Kuching Sarawak, NCUT Taiwan, Instituto Politécnico de Betano Timor-Leste as a co-host, keynote speakers, scientific committee, reviewers, and moderator for their valuable work. Most importantly, this conference is supported by Research and Community Services Center, dedicated organizing committee, and creative team who deserve my deepest thanks and highest appreciation. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
All right. Thank you, Dr. Yastab Akhtar, for a warm welcome in this event. You may now take your seat. And now, I am delighted to invite the introductory remark from the Director of Bandung State Polytechnic, Mr. Marwan Shah, SE, MSI, PhD.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera untuk kita semua. Hello and welcome everyone. Very good morning to all of you. It is my great pleasure and honor to welcome you all to this exciting event, the third International Seminar of Science and Applied Technology 2023. We are honored to have the following experts as our keynote speakers today. Welcome Professor Yen Dir Kwan from welcome Dr. Nur Zakiyah Hani binti Datuk Dr. Kamaruzaman from Polytechnic Kuching Sarawak, Malaysia, and Professor Andrianto Setiawan from our Polytechnic Negeri Bandung. I would also like to acknowledge and thank our honorable guest, Madam Aidawati binti Mustafa, Head of Electrical Engineering Department, on behalf of the Director of Polytechnic Kuching Sarawak. Welcome Professor Chen, President of National Taichung University of Science and Technology, Taiwan. We are looking your collaborations, Professor Chen. Mr. Domingos Faria from Instituto Politécnico de Bentano, Timor-Leste. Dr. Muhammad Alif Ashraf from University Technology Mara, Malaysia. Professor Muhammad Hafiz Muhammad Hanafiah, also from University Technology Mara, and Dr. Nur Adillah binti Muhammad Zain from University Technology Mara. This is the third edition of Issat, which started in 2020 as an international seminar organized only by Polban, then in 2020, to build a culture of international seminars and publications in the field of applied science and technology. At the moment, it has grown into a bigger conference that involving more speakers and participants from other countries and co-hosted by several universities from Indonesia in 2021. And this year event co-hosted by Polytechnic Kuching, Sarawak, Malaysia, National Chinese University of Technology, Taiwan, and Instituto Politécnico de Betano, Timor-Leste. Many thanks to all of our wonderful partners this year. The theme of the conference is Natural Resources Management for Environmental Sustainability. We have invited some of the distinguished experts and researchers in this field to share their insight and experiences in promoting environmental sustainability. In this conference, like Pak Jacob told us before, 98 papers were accepted as representations from 7 countries. We have also prepared a rich and diverse program for you to enjoy during this day. You will have the opportunity to attend keynote speakers, plenary sessions, parallel sessions, workshop, poster presentation over there, and exhibitions. You will also have time to network with your peers, colleagues, collaborators, or potential partners. We hope that this conference will inspire you to learn new things, discover new perspectives, exchange new ideas, create new connections, and contribute to new solutions. We hope that this conference will also motivate you to use your skills and knowledge to make a positive impact on society and the world. We are pleased that you have chosen to join us for this wonderful event. We are looking forward to seeing you in action during the conference. Please feel free to ask questions, share your opinions, and network with your peers during the conference. We are confident that you will have a wonderful time here. Thank you very much for your attention. Enjoy Bandung and enjoy the conference. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Marwan Shah, SE MSI PhD, for the kind speech to welcome this event. Mr. Marwan Shah, please stay on stage for the opening of Issat 2023. Ladies and gentlemen, to symbolize the opening of Issat 2023, I would like to ask the honorary representative from each country to hit the Indonesian drum kendang to symbolize the opening of Issat 2023. I am honored to invite the representative from each country to come up to the stage and play the Indonesian drum to symbolize the opening of Issat 2023. Mr. Marwan Shah, SE MSI PhD, and Dr. Yaakob Astor from Politeknik Negeri Bandung as the representative from Indonesia, please come on stage. Professor Yen Der Kwan from NCUT Taiwan as the representative from Taiwan. Madam Aidawati binti Mustafa from Politeknik Kuching Sarawak, Malaysia as the representative from Malaysia. Mr. Domingos Faria from Instituto Politécnico de Betano as the representative from Timor-Leste. All right. Ladies and gentlemen, please do us the honor of opening Issat 2023. All right, get ready for the opening of International Seminar of Science of Applied Technology 2023. Let's do the countdown. 3, 2, 1, go! Ladies and gentlemen, the International Seminar of Science and Applied Technology has officially started. Give a big round of applause for the representative at Issat 2023. All right, ladies and gentlemen, you may now be seated again. Although for Mr. Marwansyah, PhD, and Madam Aidawati binti Mustafa, please stay on stage for the MOU of Bandung State Polytechnic and Polytechnic Kuching Sarawang. Thank you. All right, ladies and gentlemen, next will be the MOU of Bandung State Polytechnic and Polytechnic Kuching Sarawak, Malaysia. The MOU is for a partnership in the field of education, research, and community services. Please do the honor of doing the MOU. Please sign right here.
Polban assuring your future.
Ladies and gentlemen, the MOU has officially been done. Please do us the honor of
Kuching
taking a
Sarawak
picture to capture
to
this
be the
partnership
leading edge
moment.
TVET institution. Thank you, Mr. Marwansyah, SDMSI PhD, and Madam Aidawati binti Mustafa for your time. Let's take All right, thank you. Madam Aidawati, you may now take your seat. Although Mr. Marwansyah, please stay on stage for the launching of Polban Press. Ladies and gentlemen, next will be the launching of Polban Press. I would like to invite Dr. Randes Dani Gandana Nugraha, MEDM, as a person in charge of Polban Press, to come on stage, and also Mr. Marwan Shah, SE MSI PhD, as the director of Bandung State Polytechnic, and Dr. Jakob Astor, as the head of research and community service, to do the honor of launching Polban Press. Please come on stage. All right. Ladies and gentlemen, it is now time to launch Polban Press. Get ready
Five,
for countdown.
4, 3, 2, 1, 0.
Ladies and gentlemen, Polban Now is now officially launched. Give a big round of applause for Polban Press. Please do the honor of taking the picture first. All right. Dr. Randes Dani, as the person in charge of Polban Press, please do us the honor of giving the speech on behalf of Polban Press. The time and place is yours.
Thank you. Ladies and gentlemen, esteemed researchers, honored guests, students, today marks a pivotal moment for Polban Press as we finally unveil our very own university press. More than just a facility, this press embodies our enduring commitment to the pursuit and dissemination of knowledge. Many of our colleagues in our campus have long been producing books of some sorts. As you can see on the display back there in this hall, this shows, ladies and gentlemen, that our spirit of sharing knowledge, inspiration, has long been a part of our academic life. In an age overflowing with information, the need for precise, scholarly, and insightful content has grown immensely. Our press stands a beacon dedicated to upholding the sanctity of genuine research and scholarly communication. This press offers not just repository of knowledge, but a platform where your research, creativity, and intellectual rigor can find voice, reaching out to minds across the globe. To our esteemed guests, your presence today signifies more than just a support. It's a testament to the shared belief in the transformative power of education, research, and dialogue. As we inaugurate this press, let us be reminded its true worth will be gauged by the ideas it nurtures, the discussions it ignites, and the impact it creates in our academic and global community. Thank you for coming to join us in this on this remarkable day. Here's to the beginnings of a legacy marked by intellect, insight, and inspiration. Thank you very much.
Thank you, Dr. Ernest Dandi, for your wonderful speech. Ladies and gentlemen, now let's have a look at the video of launching of Polban Press. That is such a great video of the launching of Polban Press. Ladies and gentlemen, give a big round of applause for Polban Press. Ladies and gentlemen, before we begin, please take a look and enjoy our jingle song for Annual International Seminar of Science and Applied Technology 2023.
Sunny days can turn into dark, like happiness can turn into sadness. When you feel your dreams torn apart, keep your heads up and hold on to your dreams. 'Cause a journey yet, you'll never know where you'll go. There's ups and downs and turns and curves. Enjoy the good times and have courage through the hard ones. There's no to go without the storm. If you don't chase your dreams, they'll never come to you. You've got all the strength to reach it and look under it. No matter how fast you get there, what matters is the journey that takes you where you wanna be. Sunny days can turn into dark, like happiness can turn into sadness. When you feel your dreams torn apart, keep your heads up and hold on to your dreams. 'Cause a journey yet, you'll never know where you'll go. There's ups and downs and turns and curves. Enjoy the good times and have courage through the hard ones. There's no to go without the storm. If you don't chase your dreams, they'll never come to you. You've got all the strength to reach it and look under it. No matter how fast you get there, what matters is the journey that takes you where you wanna be. That takes you where you wanna be. That takes you where you wanna be.
Well, that was such a catchy song to boost up our mood for Issat 2023. All right, ladies and gentlemen, the International Seminar of Science and Applied Technology is organized by Bandung State Polytechnic to build a culture of international seminars and publication in the field of applied science and technology. Therefore, we have this exhibition, presentation, and talks during panel session and parallel session. The next program is the panel session, which will be moderated by Ms. Anissa Syafitri Kurnia Setiawati, SST, MSc. She has obtained her Bachelor of Applied Engineering in Chemical Engineering from Bandung State Polytechnic, and she has obtained her Master of Sciences in Sustainable Energy System in University of Applied Sciences, Upper Austria. She is currently a lecturer of refrigeration and air conditioning engineering from March 2022 until present. She has also conducted a lot of research in the environmental sectors. And it is my honor to introduce her as the moderator for today's panel session. Please join me to welcome her to guide us through our discussion. Ladies and gentlemen, the moderator of panel session, Ms. Anissa Syafitri Kurnia Setiawati, SST MSc. Hello, Miss. How are you? All right, how are you?
I'm very good, so excited. I'm so honored, but also nervous at the same time, so everything at once.
Nervous is normal. All right, so you are the lecturer in Bandung State Polytechnic, correct?
Right.
So how do you feel about being a lecturer in Bandung State Polytechnic?
Well, of course, I'm very much honored and glad being a lecturer in the Polytechnic where I've been the alumni here. And this is such an honor to have this event, the international seminar in our campus Polytechnic Negeri of Bandung. So what about if we get started?
All
Nadira?
right, let's get started. So ladies and gentlemen, the moderator for panel session, Miss Anissa Syafitri, the time and place is yours.
Thank you very much to our MC, Nadira, for your warm introduction and the permission to take over this session. Dear Honorable Director and its directions of Polytechnic Negeri Bandung, dear distinguished guests and the participants of Issat 2023. Assalamualaikum warahmatullahi wabarakatuh. Good morning and best wishes to all of us. My name is Anissa Syafitri Kurnia Setiawati, and I will be your moderator through this panel session of the day. Please let me hand over these things first. Ladies and gentlemen, before we come to the presentation session, I would like to greet our participants of the event, which consists of professors, researchers, students, and professionals. How are you today? I can hear you. Louder. How are you today? Great. Nice. I'm very happy to see you here and welcome all of you to the International Seminar of Science and Applied Technology 2023. I hope we are all doing great because we are about to begin an amazing agenda of the day. And for your information, our participants come from an incredibly diverse range of fields, including soil sciences, hydrology, geology, geography, energy engineering, renewable energy, sustainable development, natural resources management, and material science. What a diversity. However, with this diversity, we will be united in the Issat 2023 under the theme of natural resources management and sustainable innovation. Ladies and gentlemen, the concept of sustainable innovation, which lies at the heart of this event, revolving around finding solutions that meet the immediate needs of society without compromising the well-being of the future generations or the delicate balance of our ecosystem. It's such a unique opportunity to explore the latest research findings, exchange ideas, and collaborate across disciplines such as artificial intelligence, renewable energy, conservation strategies, eco-friendly materials, and other cutting-edge advancement. Those are the tools that enable us to create more efficient, cost-effective, and environmentally friendly solutions in a hope that they will help us to reduce our waste, conserve our resource, and mitigate the impact of the climate change, of course. So, without further ado, let me introduce you to our esteemed panelist member who already here with us. First, Here we have a lifetime distinguished professor from Department of Refrigeration, Air Conditioning, and Energy Engineering, National Tsinghua University of Technology, Taichung, Taiwan. Ladies and gentlemen, please welcome and give a round of applause for Professor Yen Der Kwan, PhD. Professor, yeah, you may come to the stage, please. Next, here we have a professor with expertise in air conditioning, the representative of Polytechnic Negeri Bandung from Refrigeration and Air Conditioning Department. Ladies and gentlemen, please welcome and give a round of applause for Professor Dr. Insinyur Andrianto Setiawan, MT. Please come to the stage, Professor. Last but not least, here we have the one and only lady between the panelists, a senior lecturer at Electrical Engineering Department, Polytechnic Kuching, Sarawak, Malaysia. Ladies and gentlemen, please welcome and give a round of applause for Dr. Nur Zakia Hani Kamarul Zaman. Please come forward. How are you? Yeah, maybe you could introduce yourself, yeah, between each other first before begin the panel session, because I'm going to give the rules and format for the session. Please be more relaxed because it is such a casual event. Not so formal, don't worry. And prior to the starting the first presentation, I would like to explain the format of this seminar. The seminar will be divided into two main parts and a small additional fun session in between if we still have time. The first part is the presentation session from all the panelists, in which each of the panelists will be given around 20 to 25 minutes to deliver their presentation. Please remember that during this session, all the participants are not allowed to interrupt or ask panelists, because in the second part, we'll have the Q&A session. And for those who would love to ask during the Q&A session, which we are highly anticipate, please raise your hand, and once the committee give a permission to you, please introduce yourself before you ask your question and mention to whom the question is addressed. To start the presentation session, please allow me to read our first presenter CV. Professor Yen Der Kwan. He is, I would read your CV first. He is currently appointed as a lifetime distinguished professor in Department of Refrigeration, Air Conditioning, and Energy Engineering at National Tsinghua University of Technology, also known as NCUT, Taichung, Taiwan. He got his bachelor degree from Department of Aeronautical Engineering, Tamkang University, Taiwan, a master degree from School of Aerospace Engineering, Georgia Institute of Technology, USA, and PhD degree from Department of Mechanical and Aerospace Engineering, University of Missouri, Columbia, USA. His experiences started in 2001 as a project manager in Taiwan Autodesign.co. And as of August 2001, he began his academic career as an assistant professor in Department of Mechanical Engineering, Taipei City University of Science and Technology. In the next 4 years, he was already an associate professor of the same department and university. Starting from 2007 to 2010, he was an associate professor in the Department of Refrigeration, Air Conditioning, and Energy Engineering, National Tsinghua University of Technology. And from 2022 until now on, he is a lifetime distinguished professor at NCUT. Not to mention, apart from being academician, he is also an independent director of Quenling Machinery Refrigerating.co.ltd. Professor Kwan also actively participating in several organizations and holds several positions, such as President of Taiwan Society of Heating, Refrigeration, and Air Conditioning, Executive Director of Taiwan Association for Hydrogen Energy and Fuel Cell, Executive Director of Taiwan Energy Association, Director of Taiwan Cleaning Technology Association, and Director of the Combustion Institute of ROC. His research areas include direct methanol fuel cell, proton exchange fuel cell, CFD, energy management, electronics cooling, HVAC, composites, wireless power, and transmission. Ladies and gentlemen, without any more dilly-dallying, let's begin the presentation on design, fabrication, and application of the portable fuel cell by Professor Yander Kwan. Professor, the time and the floor is yours. The slide, please.
Too many slides, so it's okay. Okay, so how can I see here? Can I stand there? Stand down side. Okay. 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 Good morning, everybody. And I'm from the NCOT, and this is my third time to come to visit the Polban and also Indonesia. So I'm glad to have the chance to give a speech. And because the time is limited, so I will very quick share some of the research topic in the field cell. Because there are, I think, the many scholars or students from different departments. So today I will make a very short introduction about the hydrogen fuel cells. So not the refrigeration, air conditioning. However, in the future, we have some opportunity to have some have the cooperate together. Okay. Okay. So that's good. Yeah. So let me see. Okay. So the content we start from the hydrogen fuel cells. And also introduce what is the fuel cell, and also what is the portable for the direct methanol fuel cell and the proton exchange membrane fuel cell. Let me see. Oh, next slide, because. Okay, so why we make fuel cell? Because fuel cell, they use the hydrogen as the energy, and the hydrogen we can obtain from different. So this is like a society of the hydrogen society. So this is for the hope of the future clean energy. So the fuel cell application, they are from the very small one to the very large power generation. Whether in today's presentation, we only focus on the portable. The portable that is the hand down, so it's from the few watts to the 100 watts. And the DMC, actually, this is the hydrogen energy storage in the methanol. The methanol is a liquid. So this already diluted the methanol. So it's the advantage that it's very easy to to bring, and also the energy already stored here. And okay. Sorry, I'm not. Okay. Okay, because this is the CH3OH and the plus O2, so the product include the CO2 and the H2O. So CO2 will become a bubble in the anode side. Okay, and the pen is used the hydrogen directly. So the product is only the pure water, so it's clean and with the heat. And then I will show some of our experience of the fuel cell. So it's many, so I want to quickly review. So the conventionally, a fuel cell is look like this. Okay. So this the so there is the bipolar plate, the membrane, and also we can provide the anode is the methanol solution or hydrogen, and the cathode is air or the oxygen, and then they can make together. And then for the stack, because the fuel cell the operation voltage is very low, it's below 1 volt. So if we want to use, we need to increase the voltage. So we can have many types of the stack design. So the left one is the bipolar design of conventionally. But for the portable, actually we don't need so large the current, but we need in small size we need to increase the voltage. So we can make the planar design such as the right one. So we use some technique to make the portable one. So we call this the power is like the micro fuel cell. So some scholars they present the metal based or polymer based or silicon based, and this have some advantage and disadvantage. And what we did before is we used the PCB technique. PCB, the printed circuit board. So in Taiwan, it's the largest PCB manufacturing. Many PCB manufacturing companies in Taiwan. So we use this technique to favorite the portable fuel cell. So the tradition is the upper. So you can see the fuel cell to stack. We one by one. But in PCB process, we cannot make this like the smaller size, the lightweight, but we need to consider some of the phenomenon from the single cell to multi cells. So we propose the system on cells concept, because PCB we can make the chip mounted there, and also write some programming to make the control or the monitor. So this we make that's a component like DMC. So we can use, for example, we can define this spec. Output is 1.8 volt, and the maximum power is 3 watts. And also we use some portable and also to connect to the main controller. So we can make the different design of the 3 watts, 6 watts, or we use some demonstration for the system. This is same SOS platform. Okay. So this is another standard 2 watts, 3 watts, 4 watts, and 6 watts, and 10 watts for the modular. So we do some research is how to laminate. So this is the kind of the exploited view of the PCB process. So we use some pre-preg and MEA, and also we have some kernel collector and make them together. And from the hot press process, but the hot press process, the membrane of the fuel cell will be damaged sometimes. So we need to figure out how to reduce the damage. So this is the hot press machine. So we need heating and the cooling. So what do we consider is the 3 main factors, like compression ratio, hot press, heating time, and temperature. Then we make substitute the fixture to make like this. And so we use the gold sheet as the current collector, and so we will use the single cell, and put assemblies at the single cell, and make the whole the PCB curing process. And then we make the experiment before and after we make the hot press process. So this is the testing system. So we have the computer vehicle system. Also we have the fuel supplier. Use the water base to control the methanol temperature. And also then we have the DC loader to measurement the correctly of the fuel cell. And for the hot press picture, we need to have some heating and the cooling system. So the heating, we need to heat the center. The cooling, we want to, heating the side. And the cooling, we cooling the center. So we use this to show how to cooling. We use the air cooling. So the center line, MEA, we want to cooling area. But the epoxy, the site, we need to cooling. So we need to increase the temperature. But this temperature is about 150 or 120 degrees Celsius. It will damage the membrane. The membrane is the porous media. We need to make control of the. So then we use the pre-preg characteristic to see how much temperature we need to control. So we use the Takuchi parameter study. We make the 4x3 and make the compression ratio, heating temperature, heating time, and the hot press pressure as the factor at the different level. So we design this and make the experiment. Then we can find how much the degradation after the hot press process. We can find the main factor is the heating temperature, and the second is the compression ratio. The third one is hot pressure, and the heating time is the last one. So we can see this as the poor error. So so in the future we can make control of the heating temperature. It's dominant, and also we can make the ANOVA analysis and to make. So we can find the best combination is the case 4, and then we use this to make the 3 cells assembly as the and then we make a comparison before and after. We find the red one is we optimize the factors. So it's the performance is the higher than the before. Okay. And then we can make the anode and cathode. Anode and cathode is the DMC. We want to the methanol the fuel supply, and also the cathode, the air supply, and also the temperature management. Okay. So there are temperature, airflow, and the fuel delivery as a sustainable consideration. So at the beginning, we found this module, when we run sometime, when we make the run, probably several minutes, it will shut down because of the concentration degradation a lot. So we make the simulation. We can find your CFD, then we can find it compare with the experiment and the CFD simulation. So we can find the left cell, the fresh methanol cannot breathe. So there's no fresh. The field can be active, can be have the reaction. So that cause the fuel cell performance drop a lot. Okay, so we make some other design, and also use the CFD and also experiment. So after we make this the equal design, so we can find the sharply drop disappear. So we resolve this problem. So the performance keep stable. Okay. So we present the equal length for the flow channel, the diverge point, and also the bar flow for the bubble can follow this the slope to move out. And then because we want to use the double side, so we find the 2D to 3D, and so we make this design, and that the CO2 inside, like a bubble, can remove more smoothly. So this also uses the simulation. We can find because during the reaction we cannot find the inside phenomena, so we can only use the simulation to predict, make the design to see if this is okay design or not. So we can look this good, this good design. And also we make the stack. The stack, what we can say is we need two single inlet and single outlet. So we need to make the cold channel or like a tank inside the fuel cell. So we also make a simulation to make sure its design is okay. So the cathode side, we need a fan and the vent and the gap. Also, we need to have the good O2 supply and also have sufficient water removal and also thermal control. So also we make the wind tunnel to make the selection of the fan. And also we need to think about how much airflow rate or airflow velocity, what do we require to make the good simulation on our fuel cell. So we make some experiment like the separate flow channel or the parallel flow channel. And also this is the cathode design. We can make the simulation. So this simulation, and we make the fan and also vent. The green color, that is the vent, the open. How to open to like the fresh air go inside. So this we cut help and find out this simulation is more uniform velocity inside, and also this sufficient airflow inside, and also in a formal design, there's flooding happen when operating, so we resolve the flooding. So this is the schematic of how to make a simulation. So also the inner flow channel, there are different gap and different size. So we can ensure that all the air inside flow is uniform. Okay, so this is the simulation. Make a cross section. Ensure each channel have the uniform distribution. So this is the final design of fan. Although we make we can also make the wind tunnel experiment to select the proper phase. Okay. Then the other research is that how to make the whole design. because whole design some gap. We just random to guess 50% open ratio or how much size. So we make we adapt we use the Pareto. Pareto is the geometry deviation is the theory, and we use the practicing cavity design, and also we use the Hilbert. Hilbert curve Pareto geometry design. And what we concern is the number of hole free open ratio, and also the total length of the perimeter length of the hole, and to quantize how to make a design. And then we use the different hole array to ensure to make the further investigate how to make the whole design. And also finally we can conclude how to make the good whole design to let our fuel cell have a better performance. And then we think about how to make the lightweight. So the lightweight, we remove the metal mesh. We use the epoxy. This FR4 epoxy as a substrate, and then we coating some the conduction layer, and also the corrosion resistant layer. So we use the thermal evaporator chamber to make to coating the aluminum or copper. And we found the copper is better, but copper will damage the catalyst. So we use some of the corrosion resistant. We use the Ni as the layer of the corrosion resistance. And then we make some of the measurement about the resistance. And then finally we get the good combination, and we make the test and find the good result. And also we from the single cell we saw the multi-cell, and this we use this type DMC and use a different kind of how to design the fuel cell. And then because we want to remove the bubble inside, and for the DMC it's very small power, probably few powers. So we want to remove the bubble, and also we want to travel. So we need the low power consumption, low operating starting of voltage for the pump, so low cost, and we should have the sufficient flow rate. So we propose the magnetic fluid MF as a micro pump, this one, and there is some of the PDM steam film, and with the rotary, and also this is the magnetic there, and so when rotated, it will suck of the liquid. It's a magnetic fluid will be okay. So then we remove this because we need to make it smaller. So we remove this, and then we can this show how the mechanics of this to do. And this is the second pump. And then the result we can find that we can use the very low voltage. This below to 1 voltage, and we can get the good flow rate to provide and also the second, we even below the 1 voltage, so we can also operate the micro pump to do. And this is another. So the micro pump, the power consumption only 0.003 watts. So we use the 100 of the fuel cell.
Yeah, Professor Kwan.
Yeah.
Maybe I'm sure that you still have a lot of explanation on MF, but maybe we could go directly to the PMFC.
Okay, PMC.
And
Okay.
yeah, in
good.
10 minutes we'll finish this.
Okay.
Thank you.
Because this is the DMC, so we have another DMC. Oh, because this is the. Okay. Okay. So the PMC, we also did some of the portable. So we use the graphene thin film to the current collector. This uses the MEMS or nano technique, like you can use screen printing or graphene suspended spin coating. Also use the RF microtron to make this. And also make the single cell test. We can compare different techniques and find the better one. Okay. And also, we can find the stability is also good for this single cell pan fill cell. And also, we propose the reinforced composite laminate. So the composite, how to make the process, okay. And also, so we make from the carbon cloth, and we add some powder in the epoxy, and then make the hot press. Then we put in the furnace to make the harmonization, to remove the carbon epoxy, resin epoxy, and also left only the carbon. The carbon that have the good electric conductivity. So from left to right, so this like the use the reinforced composite, and also we make this as the single cell to make the experiment to show some result. And also we use the carbon nanotube for the pen current collector. So this is more thinner. We like a paper, we added some nanotube, and also this how to make this. Okay. And then we use some spray coating and the different technique to add the nanotube inside the current collector. And also this comparison of the performance. Okay. Okay. And also we make the stake. We use by ourselves. We use in the lab. We use the machining and to make the metallic or use the carbon plate to assembly our own 100 watts pen fill cell, and to make an experiment, also make some electrochemical the test. Okay. And also we make the control and to that it can be provided the power to. Okay, so this is the figure. And also we make the experiment. Also we compare with some of the commercialized product. Okay. And then we use the PSAC. Right now, at the beginning we use PSAC. And later we use another chip to do this. And then this is how to control the 100-watt pen fill cell stack. Okay. And also we want to make this more stable, and we consider the hydrogen consumption. So the right one is ours compared with the commercialized. We can use the less hydrogen and to operate it for longer time. And also we make the fuel cell vehicle. So the student use the aluminum alloy or the other to make the frame. Okay, and then we make another suspension system. And also we make the student make the power and the transmission system. And the business. So the fuel cell car is always the team is organized by the undergraduate students, the third and the fourth year student. We have a competition, and also we make how to make the test. Every year we have the competition to do this. Okay. So up to now, we already have several, probably 8 cars. So we make the test and the competition, and okay. So because of time, thank you.
Wow, wonderful. Thank you, Professor Kwan, for your very comprehensive explanation regarding portable fuel cell design, fabrication, and applications. Anyway, this is it for the first presentation session. Thank you once again, Professor Kwan, for the explanation. And you may now enjoy your time. Next. Ladies and gentlemen, we are about to start the second presentation session, which will be delivered by Professor Andrianto. But before we dive in, please allow me to read our second panelist's short CV. Professor Dr. Insinyur Andrianto Setiawan, MT, has done his bachelor degree in Bandung Institute of Technology, also known as ITB, majoring in engineering physics. And right after that, he continues his master degree in the field of instrumentation and control within the same institution. And as for his doctoral degree, he took mechanical engineering at Gajah Mada University, and currently he teaches in the refrigeration and air conditioning department, and the course he teaches are air conditioning systems and air conditioning system design. As of now, he holds 2 positions in 2 different organizations. The first one is as a head of group of expertise of air conditioning in refrigeration and air conditioning department at Polytechnic Negeri Bandung. And the second one is as the chapter technology transfer chair of America Society of Heating, Refrigerating, and Air Conditioning Engineers, also known as ASRE, Indonesia chapter. Additionally, his research interests are revolving around the air conditioning, refrigeration, and two-phase flow. Well, this is pretty much about Professor Andrianto, and we'll hear more from him directly right after this. So, are you ready, Professor? Ready, good. Ladies and gentlemen, without additional delay, let us welcome the presentation session from Professor Andrianto Setiawan on opportunities and challenges in the use of dimethyl ether, aka DME, as a refrigerant. Professor Andrianto, the floor is yours.
Thank you, Anissa.
Please give round applause.
Assalamualaikum warahmatullahi wabarakatuh.
Indonesia, as for high energy consumption, also for oil and gas. And the energy consumption in Indonesia in 2022, the energy consumption reaches 8.2 million tons. It's really about 4 million and it's the world of 78 trillion in value. Meanwhile, domestic demand is very high, it's about 8.5 million tons per year. And while Indonesia continues to increase in import of LPG, it is because the LPG production capacity in Indonesia is still about only 1.9 million tons per year. So that import are needed to the shortfall of LPG supply in Indonesia. Most of LPG in Indonesia are imported from United States, the Arab Emirates, Saudi Arabia, and the other are from Qatar, Bahrain, Oman, and Nigeria. Due to the dependence of the huge consumption of LPG that was imported, the government of Indonesia instituted LPG regulating in 2028. And the government has to build factory that many from public gasification. And the ground building has been carried out by the President of Indonesia in January 2022. And the factory is located at Kuala in Sumatera. Why I mention LPG while opening up the seminar is the energy. Yes. In the next, the government applies to substitute LPG with TNT and starting in 2028. The consumption of LPG will be reduced by most of the and LPG is important. Aside from fuel, TNT is also used as refrigerant. And what is the compound
will discuss about the desired properties of refrigerant. A refrigerant should have a low freezing point and high evaporating pressure, low ODP, low ozone depleting potential, and low GWP, low global warming potential, and also low condensing pressure and high critical pressure. Let us discuss one by one. Well, the properties of refrigerant can be categorized by 4 categories. It's thermodynamic properties, chemical properties, physical properties, and other properties. The thermodynamic properties of refrigerant, the highest properties are, first is low boiling point, then low freezing point, positive pressure, both in condenser and also in evaporator, and then high latent heat of vaporization. Well, low boiling point is needed because a refrigerant should be used to cool the surroundings, so that the boiling point should be low enough. And the dimethyl ether we'll discuss next has a boiling point of about minus 24 degrees Celsius. And also a refrigerant should have a low freezing point, because in a refrigeration system only 2 phases are allowed, that is liquid and vapor phase. No solid is allowed in a refrigeration system. And positive pressure in condenser and evaporator are needed, because if the pressure is negative, it can be a risk for leaks of surrounding air to the refrigeration system. And high latent heat of vaporization is needed, because with high latent heat of vaporization, it can handle a large amount of cooling with a small amount of refrigerant. The other properties, chemical properties, non-toxic, yeah. It is needed because toxic compound can danger the worker or the operator of the air conditioner. Non-flammable and non-explosive are also needed, because with non-flammable and non-explosive, the refrigerant will be easy to handle. And non-corrosive is also needed, because with non-corrosive, the properties of the refrigerant can stay in a longer time. It should also be chemically stable and no effect of the on the quality of the stored product. And the physical properties of refrigerant, the needed physical properties is low specific volume, so that it only occupies a small space. And then low specific heat, so that the characteristic of the refrigerant is constant and easier to control. And then it should have a high thermal conductivity, so that the refrigerant system has a high heat transfer. And it also should have a low viscosity. With low viscosity, a refrigeration system will have a low pressure drop and a high efficiency. And high electrical insulation is needed for ensuring that the refrigerant will not cause a short circuit in the electrical system. Well, we now focus on the DME, dimethyl ether. The dimethyl ether has a very
and also it's enough for isolation information. And in regards to R174A,
would replace R134A. Another advantage of RU170 or DME is its low global warming potential in comparison to R134A. We can see here. R134A has a global warming potential of more than 1,400. So that seen from environmental impact, DME or dimethyl ether is much more superior than that of R134A. And also in saturation pressure. From the saturation pressure aspect, DME can be used as a substitute for R134A because it has a similar saturation temperature both for vapor and liquid. Yeah. So that seen from saturation pressure, R134A could be replaced by DME. This chart shows our study of dimethyl ether in horizontal condenser. Yeah, but it's too technically, so that I will skip this slide. It's also too technically. Okay. Yep. Now we'll discuss about the performance comparison of dimethyl ether and refrigerant R134A. Yeah. We can see here, if it is seen from the cooling capacity, yeah, the cooling capacity of DME and R134A is almost the same. It's not the same. It means that power consumption, if seen from the power consumption, DMA has a power consumption lower than that of R134A. The orange line shows the power consumption of DMA, and the blue line shows the power consumption of R134A, so that we can see here that DME has a lower power consumption than that of R134A. What if the subcool is set to 4 degrees Celsius? Yeah. The advantage of DME now is 8.8%. It can reach 8.8%. DME more efficient than that of R134A. Also, we can see in this chart, that in all range of subcool and all range of superheat, DME is superior to R134A. This is another chart that show that the DME is superior over R134A. Now we talk about the challenge for the use of DME. Well, in the aspect of COP, power consumption, and overall efficiency, DME is superior to R134A. But DME, dimethyl ether, is a flammable material. Yes, flammable material because DME is a fuel. And the second challenge to use the DME is it can cause irritation to eyes, to nose, to throat, and to respiratory. And the third challenge to use the DME is it can dissolve the rubber-based material. Then it can cause leaks in the refrigeration system and can reduce the quality of the refrigerant. Next slide, please. Next slide, please. Yep, okay. So that we can conclude that DME has advantages, several advantages. In terms of cooling capacity, DME is comparable to R134A. But in terms of power consumption, DME system, dimethyl ether system, consumes lower energy than that of R134A. Now, the overall performance of DME is superior to R134A. So that this 3 point shows the advantages of DME over R134A. But it also has disadvantages in terms of its flammability, and it can cause irritation. Also, it can dissolve rubber-based material. So that in the future study, I recommend to do research on the use of DME and its mixture to minimize its flammability effect. And the second, when use the DME, dimethyl ether, as refrigerant, the materials for refrigerant system should be selected, especially for the shields, so that they do not dissolve. They do not dissolve in dimethyl ether. It is aimed to reduce the risk of leaks in the refrigeration piping. Also, the selection of material for manifold hose seal should be done with carefully. It is aimed to prevent leaks when charging or discharging refrigerant from the can, from the refrigerant storage to the refrigeration system. Yeah, it is my recommendation when we use dimethyl ether as a refrigerant in an air conditioning system or refrigeration system. And the important finding in this research is that thermodynamically, DME or dimethyl ether can be
used to replace, to substitute R134A with even better overall performance, with even better efficiency. Thank you all. Thank you. Thank you.
Ladies and gentlemen, please give a round of applause for Professor Dr. Insinyur Andrianto. Thank you, Professor, for the insightful presentation. And apparently this is the last part of the second panelist presentation. Thank you very much again, Professor Andrianto, and you may now enjoy your time. And now, as we are heading to our last panelist, please allow me to read the short CV of Dr. Nur Zakia Hani Kamarul Zaman. Dr. Nur Zakia Hani Kamarul Zaman is a senior lecturer at Polytechnic Kuching, Sarawak. She received her degree of Bachelor of Electrical Engineering from College University Tun Hussein on Malaysia in 2005, with dissertation title of Electromyography for Paralyzed Patient. And then she continued her study within the same university, and she got the title of Master of Technical and Vocational Education through her dissertation entitled Pembelajaran Mastery dalam Kalangan Pelajar Politeknik Malaysia. And so finally, she got her title on doctoral degree as a Doctor of Education from University of Selangor in 2017 with dissertation title of Ciri-ciri dan Amalan Kepemimpinan Kejuruteraan dalam Kalangan Pelajar Diploma di Politeknik Port Dickson. In addition, from the enlisted researches she has done, Dr. Nur, please feel free to correct me if I'm wrong. I have noticed that there are several publications related to the electronic engineering, in which most of them are also strongly related with vocational education. That's right, right? All right. So I'm expecting that we will be informed further for the next panelist presentation session. And without further ado, ladies and gentlemen, let us welcome the presentation session from Dr. Nur Zakia Hani Kamarul Zaman on Green TVET, Role of Malaysian Polytechnics in Sustainable Environment. Dr. Nur Zakia, the floor is yours. Welcome.
Number 5, gender equality. Number 6, clean water and sanitation. Number 7, affordable and climate energy. And number 8, decent work and economic growth. Number 9, industry innovation and infrastructure. Number 10, reduce inequality, and until number 17, which is partnership for the goals. So this is the main document that we are referring to construct our activities, our aims, and our goal, which is Green Tibet to produce more sustainable environment. So this is the first document. So next we have Global Reporting Initiative, which is GRI. Okay, the GRI is a standard reporting on sustainable activities, which what we are doing in the institution all over the world. So in this Global Reporting Initiative, so we have to report about 5 areas, which are on areas 302 on energy, areas 303 water and efficiency, area 306 which is about waste, 308 about supplier environmental assessment, and finally we have area 404, which is training and education. So by using this reporting initiative, we are efficiently produce reporting on our sustainable activities. Next, from Malaysia we have 12 Malaysia plan, which we call as RMK. Okay, this is the 5 years plan. So in this plan we have 2 focus area, which is developing future talents and also boosting digitalization and advanced technology. So by using this documentation, we have several activities